everyone. I am Alan C. Smith, Certified LabVIEW Architect, Consulting Software Architect. I'm just ACS on the forums. I'm a LabVIEW champion. And this is Actor Framework everywhere. And what am I talking about today? What's our stage? Let's set a scene here. Two households, both alike in dignity, in fair LabVIEW, where we lay our scene. Shakespeare ran an illicit LabVIEW user group out of the back of the old Globe Theater. Scenario. I have a shop with a lot of developers. I have some folks who really like and are really proficient with Actor Framework words. They have a body of code they want to use, good stuff, tested stuff we all like. I have other people, other organizations, other departments with competent LabVIEW developers or TestStand developers who are not Actor Framework developers. And we would like to get these kids together. Okay, we would like to be able to pull that Actor Framework code into the larger environment, tester control environment. All right, so quick question to the room. Who here is a Montague, Actor Framework developer? I got a couple. All right, cool. This actually is going to work out because who is a Capulet? A LabVIEW TestStand, regular LabVIEW developer. Okay, this is all right. Right, this shifts the presentation ever so slightly because I emphasize some things or de-emphasize others depending on who's in the room. And you're not getting the Shakespeare references. Oh my God. Okay, enough of that. Yeah, so that's our scene, right? Do you guys, is this a scenario for both you, my AF and non-AF people? Is this a scenario that resonates with you? Do you see this? Like, I can't use your code, Dave. It's all Actor Framework. I have no idea what's going on. Does that sound familiar? All right, we're going to talk about addressing that today because we're that cool, right? We're going to fill in that bubble. What I'm going to talk about. The first thing I need to do, those of you who are not my AF developers, do you have any AF knowledge? How many has like barely heard of Actor Framework? Okay, that's a good chunk of the good news is I'm going to teach you everything you need to know about Actor Framework in about 5 minutes. Nobody believes me. That's okay, I'll prove it to you. Then after I do that, and that is so my non-AF people can keep up and understand what we're talking about here, then we're gonna talk about calling that Actor Framework code from your code, how to do it. It is a collaborative effort between you and the AF developer. My 3 AF guys, you're here you're my other at this point. After that, so short processors, actors in queued message handlers, which includes DQMH, and then actors in synchronous systems like TestStand. Then we will talk about actors in distributed systems. So we will go from intra-process communication to inter-process communication, crossing an application boundary. How can we do that with Actor Framework and other stuff, which doesn't even have to be LabVIEW? And then just a little bit more about where you can find more Actor Framework because I'm going to convince all of you and you're going to want to run out and learn more. First, everything you need to know about Actor Framework in 5 minutes. Okay, everything you need to know to follow this presentation. An important caveat. Does anybody here not recognize this? I see 0 hands, perfect, okay? Queue-driven message handlers, we love them. We've been using them for 25 years now, 27 years, long time. Here is a fun fact. That is true for Actor Framework, that is true for DQMH, that is true for, I think, the other frameworks that we look at. They're all queue-driven message handlers under the hood. Same, okay? Conceptually, the details matter. High level conceptually, they're the same thing. So, actors have private data, so does a queue-driven message handler, right? Private data is, we have that internal cluster that is the private data that the queue-driven message handler acts on. That role is filled by the cluster of class private data in the actor because an actor in Actor Framework inherits from a class called actor. It's a class, it has class data, just like the private data in a QMH. They have tasks that they can do. They have code that completes certain tasks. So in the queue-driven message handler, it's a case in the case structure, okay? That role is filled by a method of the actor class. So everything that would be inside of the case structure is inside of that post fill limit case. You would find inside that post fill limit VI of the corresponding actor. Okay, an actor that was the same thing. We can address both of these things. Queue-driven message handler, I just get the queue. When I make the queue for the QMH, I share it out to the rest of the system. When I launch an actor, I get a queue back. Okay? The only difference here is the QMH is on a block diagram that you're looking at. The actor has been launched and is running in memory. You can get to that block diagram. It takes an extra step or two. But you have the address for both of them, and it's the same concept. When we have messages in both systems. It is a queue-driven message handler. A message for QMH is an identifier, a string or an enum. I like strings personally, but a lot of people like enums, sure. And the data that goes with it. So I've got an identifier for the message and the data that I need to execute that message. That role is filled in Actor Framework with a message class that invokes that task VI that I was talking about. So post fill limit message, I'll show you how to send it in a minute. When the actor receives that message, it will do post fill limit. It's the same thing. It's the same thing. Okay? So on the left, that's how I send post fill limit to the QMH, right? I take the identifier and the data, I have some way to bundle it up and put it on the queue. It shows up in the QMH, we process it. We all know how to do that. Actor Framework, that message class, that post fill limit message class, has a VI called send post fill limit. I wire in the queue the address of my actor and the data, and it happens. Okay, it is same. This is equivalent. This is an equivalent operation. If you recognize the bottom, what you know about the bottom line applies to the top line. I create the message handler, actor or QMH. I send it a message, and it's the same way. I invoke a VI, okay? And I send it a stop when I want it to stop functioning. Okay, they are the same thing. Wrapped up differently, we manipulate them differently, but they do the same work in the same way. I'm gonna teach you about this much OO. I'm gonna teach you a little bit about interfaces. I'm not going to a deep dive. I'm only gonna talk about interfaces as they pertain to using an actor. An interface in OO is simply a different handle that I put on a class. What it means in practice is that if I have this device caller interface and I say device proxy inherits from that interface, that means device proxy now has that same set of methods. So that post fill limit is a part of the interface. And then because of the way Actor Framework is structured, I can take my messages and point them at methods inside of the interface instead of at the actor. So from the perspective of the non-AF developer, what this means is that your AF developer is going to say to you, we are using this actor. It reuses these messages. The messages happen to be in another library. But everything I just showed you about calling a message applies. It's the same thing. Okay? So from the non-AF user perspective, that's all you need to know. Does that make sense to everybody? Anybody horribly confused at this point? Yeah, question.
I don't have any question, but
You're a little confused.
Yeah.
Okay.
Just this part, by the way.
Just this part. Yeah. So literally, when I have an interface, if I make a class and I said it inherits from this interface, what I'm saying is this class can now have the same methods as are in the interface. Okay. So I'm adding some new tasks to that class. This class can do these 5 things when I start. I have an interface with 4 things. Now my class can do 9 things. And I make messages that point to it. Obviously, if you're actually doing OO development and you're working with interfaces, there's more to it than that. But if you're just doing non-OO and you're playing with AF, that is the thing that you need. That's what you need to understand about it. We don't have to go any farther than that. And if you're clear on that, then we're good. Okay? Awesome. So, Actor Framework at a glance. Actors are queue-driven message handlers. Yeah, right? Actor methods, the VIs of an actor, replace the cases in a QMH. 1 for 1. When you launch an actor, you get a queue. That is the address. With that queue, actors also have messages. Each message invokes one of those actor methods. So you send a message to make a task happen. And the actor's messages may be in an interface library. They may be separate, okay? To send a message, wire the actor's queue to the send VI of a message, and you're done. It happens, okay? From the perspective of the non-AF side of this equation, those are the things you need to understand. How much OO is in that? Very little, okay? So when this is a thing that I've come to realize is we've kind of misrepresented Actor Framework, saying you have to know a ton of OO to work with it. You don't need a ton of OO to get started. You need a little tiny bit that you can teach in an hour or so, okay? Kind of core 2 level stuff. All right, so with that in mind, let us talk then, you and I, of calling actors from your non-actor code. First, I want to talk about short process actors. First, I'm going to hydrate the presenter, because this is thirsty work. All right, what is a short process actor, you ask? So I teach you, I want to teach you something about specifically Actor Framework. Maybe? Yes, okay. So actors have a life cycle, and as do our queued message handlers, right? They have a life cycle. I'm going to launch the actor, which is just, it's the same thing as you start the QMH running, okay? And then it's gonna run. It's gonna run until I tell it to stop, and it's gonna receive messages and process messages and do its work. And then at some point, we're gonna tell it to stop. And when we tell it to stop, it is going to return its final state to me. All of its data is gonna come back to me in a final message to caller. The exact equivalent in a QMH would be taking that internal cluster on the shift register and wiring it out and going off and doing something else with it. So the QMH processes some data, and you take that internal cluster and you go do stuff with it. Exact same thing, okay? So your AF developer, I did mention that actors are classes. If you have a class, there's a concept of dynamic dispatch and override, where the parent says, here's the thing I can do. The child says, oh, I'm going to fill in what I do there with an override. My AF people will understand what this is. If you're going to make a short process actor, what your AF developer is going to do is going to override actor core, which contains message handling, but then they're going to add some stuff to it. And what they're going to add is whatever the short process is. And what I'm showing you here is I've acquired some data. I've acquired a signal. And once I'm done acquiring that signal, you can see the stop right there that's got the little arrow and the stop sign on it. I'm going to tell myself to stop. So the actor is going to run, acquire some data, stop. What does an actor do when it stops? Returns its data to its caller. Okay, that is a short process actor. It's a fire and forget tool. Launch the actor, it runs, it stops, it returns, it gives you your data back. We have a VI that encapsulates that entire behavior for you. Horrible name. It was developed to test actors, actually, in an automated fashion, but we can use it, we can repurpose it here. I should have changed the name when I rolled it into AF, but I didn't. Test launch for nested actor without caller. What that will do, that cube, that waveform there, that's an actor. That's the short process actor I just showed you. I pass it into this VI. It's gonna run. It's gonna stop. I'm gonna get the class back. The class is generic actor type, so I have to say, no, it's actually a waveform, and then once it's that, I can get the signal out. My non-AF people, now that you know about test launch for nested actor without caller, think you could put this in your code? I mean, stare at it for a minute or two, sure. But this is simple, right? This is very straightforward. Solidly in the wheelhouse of a non-AF developer. Okay, there is a demo that I have for this. The demos will be available online after. I did not make the repo public before today, but I will before the week is out, I promise. Where's my demo? Here's my demo. You can't see it yet. I'm bringing up the short process demo. Let me slide it over here so you can see it, right? All right, so there it is, short process demo. Quick look at the block diagram just to prove to you that my mouse is missing. There it is. Just to prove to you that I'm not in fact lying. But that is the exact same code that I just showed you on the slide, okay? I'm gonna run it. I go and I get away from it and I'm done, okay? Dirt simple. You don't even have to open test launch. You can just wire that actor in and it goes. Your AF developer says, 1 sec. Your AF developer says, that's a short process actor. Go ahead and do this to run it, and you're good to go. Yes, sir.
What would be a good use case for a short process actor? Why?
I need to process a bunch of data. I'm going to go acquire. I want to go acquire a signal, and it's not a continuous acquisition. I'm going to go get, 1,000 data points off of this channel, and I want to get the data back.
But would you want it to sit alive? Why would you want it to go and come back and not be run?
So do you ever acquire a chunk of data where you go acquire that it's not a continuous acquisition, you acquire a chunk of data and you're done?
Usually it's continuous. Usually there's some reason to repeat.
Yeah, usually there's some reason to repeat. If you're repeating, you're not doing this. It might be something else. Maybe I'm going to, I want to process a signal. I'm going to get some data and I want to process that signal in parallel with everything else because I don't want my main application to wait while I churn through this long processing. That might be another reason. Okay, rendering a picture, right? I'm going to send some data to the database and I'm going to stick it in this short process actor and I'm going to wander off something else trusting that my database write will happen. I'm not going to wait for it because that maybe takes 15 seconds. Those kinds of things. Okay, good question. One of the cool things I like about Actor Framework is that we have the whole concept of we don't have to have the whole application running all the time. We can have parts of it come and go. That's a selling point for me. Anyway, that's a short process. Okay. Where do you get this guy? Well, you have it right now. Test launch for Nested Actor without caller is in VI Lab Actor Framework testing support 2025 Q3 or later. It should have made it, it's part of the open source update. It did not make it into the palettes at this point. It should be in the palettes very, very soon. Maybe in July. I think we have it in July. If between now and then, if you really, really want it on the palettes, you can install this package, Actor Framework 2024 for 2020, which is on vipm.io, which is the open source proceeds. That is what got rolled into the product. If you install this, you have the exact same code that you have right now, plus the palettes, or you can wait a couple of months and it'll be on the palettes. All right? Thus endeth the short process discussion. Any other questions on that? Right, moving on. Let's get a little more interesting. Let's go to the more continuous use case where we have an actor that we're running and we want to talk to it from a queued message handler. So I have this really cool actor that I have put a tremendous amount of time into getting just right. And it monitors a tank, monitors the level in a tank, and it will report back to me some stuff, right? So it will actually, I can tell it, there's that interface again, right? It uses this interface, and I can tell it to start, I can tell it to pause. It will send me messages. They come out of an interface as it happens, and it will send me information about how full is it, have we gone past, are we full, are we empty, do we have an error, device fault that I need to report? It will send me that stuff. And just to show you, because we'll be visiting this guy often, he's worth calling up all on his own. And this is just the launcher. If you look at that, it's just it calls launch root actor. I can run that, and here's my device, right? And he's just going along, and that's the weirdest signal I think I've ever seen. But there it is. And you can see what he gets. He gets to a certain full, and he shows full, and we drop slow, he stops low, and I can, it'll send an error if I happen to have one and stuff. And we'll visit this guy a couple of times. This is an actor, which my non-AF people will never touch, but you might want to use this, right? Let's go ahead and stop, go away, thank you. So I have this actor, it's cool. I like it a lot, and I want to continue to use it. But I need to use it with you guys who write queued message handlers. And you've built this whole infrastructure, this whole architecture of QMHs, which is not going to change because you have as much investment in that as I do in my actor. So we have to bridge this gap. So here's the good news. Remember what I said that QMHs and actors are same? They are the same thing because if you think about the three ways we move data around in LabVIEW, we have tags, we have streams, we have messages. Both the queued message handler and the DQMH module and actors operate in message space. They trade messages around. It's how they get stuff done, okay? So if you are my non-AF developer You already know how to talk to this, right? I showed you that. You know how to launch an actor now. You know how to send it messages. Any LabVIEW code can do that. You know how to stop it, right? You hang on to that queue, and when you get done, you send it the stop message, which is just another message, and it stops. Cool. Solidly in the wheelhouse of most of the people in this room. The thing that you're going to struggle with is, how do I get data out of it? How do I get it to send me data back? How do I handle that message that comes back? I don't know how to do that. I don't speak that language. I need a translator. Turns out it's another actor, that sits between my QMH and my tank. Okay? It's called a proxy, and it is basically, it's a thing that pretends to be this other thing so that we can control how you talk to it and how you get answers back from it. So the actor that you're actually going to launch is this proxy, which as far as you're concerned is a tank. You're going to launch it, you're going to send it some data, okay? The actor framework person, she's going to take and write that for you, and she's going to make this device proxy, and she's going to override actor core again. And that's like the piece that she might need to do. But the thing I'm about to show you, by the way, these device proxies initially are likely going to be something written by your AF developer, but they are very straightforward and very formula in terms of how you do it. And so they are an excellent starting point for a non-AF developer who is trying to learn to work with AF. Okay, because you're going to work on translating messages back and forth, and you're rewriting an actor, so you'll get some of those mechanics down. What you're going to do is you're going to override actor core again, dynamic dispatch VI. The proxy is the thing that actually launches my tank. So I've got a QMH up here, and it launches a proxy, and then down here it's got the actual actor that I care about. Okay, and it's going to go ahead and hold on to that enqueuer so we can talk to it, right? Then we're going to set some messages on this QMH device proxy. It's going to take all the messages. We're going to say that it inherits both the messages to the device and the messages from the device, because it has to handle all of them, right? We're going to set those additional methods on there. So a device proxy is going to know what to do with a start message when it gets it. It's going to know what to do with an update tank value when it gets it. And what's it going to do? The calls we already know how to do, right? You know how to send, you know how to tell it to start, send it a start message. And then the device proxy, when you get the data back from the tank, now you can put it into QMH form, right? And I did forget to mention that when you launch this guy, one of the things that it gets is it does get your QMH queue. So you put that inside the device proxy actor, you pass it to it as data. Forgot to mention that, sorry. So when you come down here, I can send in a message, cool, and now I know how to send messages back because I have the address, and I know, because I'm writing this proxy for this other system, I know I'm going to have an update tank value message, and I'm going to want to pass it some data, and you should know how to do that, okay? We all know how to do all the little tasks. Software design is about figuring out where in the code you do them. So I'm going to prove to you that it works, because why should you believe me, honestly? All right, here we go. That is the QMH demo. Call this up for you. It's going to call that exact same tank eventually with the proxy in the way, but this is all the same stuff, right? I literally just showed you these guys. So there's where I'm launching the actor and I'm telling it to start, for example, okay? And the return, the update tank value is just a normal, I get the tank value and I turn the variant back into data, right? Stuff we do all the time. Okay, and I can run it. And the tank is launched, and there it is. It's the same tank. And now look, I'm getting the data. And now I'm getting that in full. And now I'm getting a simulated device error that's being reported by a message as well. Okay? Questions on that? Make sense to you guys? All right, cool. You should be able to, this is, you start the example. It's not complicated at all. All right, now, that is so straightforward, by the way, that I'm pretty sure I can script that. I can turn that into LabVIEW scripting and probably write a tool to build this for you. More about that later. Okay, so that is the queued message handler case. And by the way, that works for a DQMH module, right? Because inside, how many of you do DQMH? All right, cool. So my DQMH people, you know that you have that the actual message handling loop is a queued message handler, it takes a regular queue. So you could pass that to an actor that the DQMH module launches, or you can use the DQMH API and call it, well, you would still want to pass in the queue so you know how to send messages back. No, even then, you could either do the queue or you could do the DQMH API, right? You know how to send a message to a single DQMH module. Just make those calls from the proxy, the same idea, okay? Because they're same, they're all queued message handlers. It's just a translation issue. So synchronous systems, let's talk about that. Let's take what we now know about this bridge code and let's go one more level of complexity up and let's talk about synchronous systems. Who can give me an example of a synchronous system? Anybody? Bueller? Anybody? What's a synchronous system? Like maybe, Synchronous system, anybody idea? No thoughts? Maybe a web service, right? Because HTTP is command reply, right? TestStand? Anybody use TestStand in the room? Right? Your TestStand. I do A, then B, then C, then D. Very synchronous. Yes, you can run stuff in parallel, but by and large, TestStand sequences are very linear. Anything where this API makes sense is a synchronous, this railroad track scenario, right? That is a place where you're doing synchronous calls to the device. So how do we support that with Actor Framework? All right, my non-AF guys. This next stuff is once again solidly in your wheelhouse. At this point, you probably need to know how to make a class so that you can make this little wrapper, but that's minimal knowledge. You know how to launch an actor by this point. We've been doing it the last 42 minutes. And you know how to send it a message to start, and you know how to tell it to stop. No change from the queue message handler scenario. We are once again bedeviled by how to get data out of the actor. And now our complicator is we are no longer same. We are no longer queued message handler to queued message handler, just change the type of message. Now we're talking about tags and streams. Now we're talking about single point data that we just want the last value, or we're talking about I want that waveform out. Okay, different scenario. Similar answer. A little bit more complicated, as I said. We are going to rely on some shared references, right? If you think about it, that queue from your queued message handler is a shared reference. We're going to talk about a slightly different set for this case, okay? That synchronous device, that very linear API is going to have a set of shared references, and those are going to be shared with a different version of the device proxy, okay? And we're going to use those shared references to translate the data. So create changes a little bit. Here's one way you can do it. I'm going to show you a better way when we're done. But we're going to go ahead and make for a stream, I like queues. For a tag data, that's where a DVR might be useful, okay? Or you can use a notifier or something like that as well. And I'm going to create those, and I'm going to store those in both the device proxy. Where's my mouse? Right, this is the device proxy. I'm going to put the data there, the references there. I'm going to put the references in my synchronous device. Okay, now I have them in both places. So now when my actor, my device, my tank, produces a value and it sends that message to the proxy, instead of getting forwarded along in a QMH message, I'm going to put it in the tank data queue. Okay? And then up in the synchronous device, when I want my tank data, I'm going to go flush that queue and get the last n values, last 47 values out of the tank. And now I have that chunk of the tank waveform. Make sense? Okay. So, this works great in LabVIEW. My TestStand guys. What happens if I create a reference in create.vi in a test step, and then I go on to the next test step? What happens to the references?
You don't have them.
You don't have them anymore. They go stale. That's exactly right. They go stale. NI LabVIEW, the VI becomes unreserved for memory. LabVIEW comes along with a little broom and sweeps them up and throws them out. That ain't no damn good for what we're trying to do. We got to do something a little bit different. We need to create those shared references in a VI that we know will stay in memory until we hit destroy at the end. We have that VI. We know what that VI is. It's any VI inside of the actor, because the actor, my proxy, is going to be running until I tell it to stop. So my AF developer is going to go get into something called pre-launch init. That is another one of those override VIs that comes with Actor Framework, comes part of Actor. And what she is going to do is she's going to, the only thing about pre-launch init is that it does some things for us. First of all, it runs, when you launch the actor, it runs right away. It's the first thing that runs. So it happens right off the bat. It will remain reserved while the actor is running because it's a part of the actor that stays in memory, is constantly running. The VI itself doesn't run, but it's a part of a VI that continues to run. And then the third thing that it does that we know for a fact, and this is an Actor Framework fact, is that pre-launch init will complete before launch actor returns. That's just something we know. It's an aspect of the framework as a part of the design. It's a guarantee that you have. So we can use that fact. We're going to change what we do in that create, that top API, where we need to have an exchange, right? We need pre-launch init to make those references, and we need to get them back from the actor. So we say, great, I'm going to make a different DVR, a one-off. It's an exchange DVR that will eventually contain, or very soon contain, those references for us. I pass that reference into the proxy. Okay. Inside, and then we launch the actor. And then inside of the proxy actor, that's where we make the references. We put them into the exchange DVR. We exit pre-launch init. Okay. We get out of pre-launch init. We leave root actor, launch root actor. I know pre-launch init is done. I know for a fact that I have those references inside the exchange DVR. So I get them out of the exchange DVR and I proceed just like I showed you. And then of course, my AF developer is going to be a good AF developer and is going to clean those references up on init or stop. Okay, if you are not an AF developer, you don't need to have followed all those nuances. Okay, for the 4 or 5 of you who are AF developers, when your non-AF person comes to you and says, I need this, that's what you're going to do. Okay, non-AF folks know that if you follow that, awesome. If it's a little confusing, it's okay. It's not something that I would expect a non-AF developer I was working with to handle. Again, if you're the AF person, you're going to do this. I'll prove to you again that it works. Okay, here's my synchronous demo. And it looks the same on the front panel, unsurprisingly, because it's doing the same job. But the API is very, very different. No longer queued message handler. Now I am using it like I might use DQMH. Okay? Create, start, go into a loop where I read the data. You know, when I decide to be done, go ahead and stop it and be done. Prove to you that it works. Because I like proving to you that my stuff works. There's the tank, there's the data, right? There's a device error that I can choose to act on. Okay? Let me show you one more thing. I have up here a little query that I can make of my actor, and I can say, can you please give me, I picked it to be 10. Oh, I'm not broadcasting. Why not? Huh. Oh, because I've got a device error going. Let me clear that error. There we go. Let me get I want the average of the last 10 samples. I'm going to tell the device proxy, give me the average of the last 10 samples. I can change that value. So it's not as simple. It's like I'm sending a message with some data, 10, 8, 47, whatever. Give me that average back, right? And we can do it at different times and I get a different value. But if I look in here, I'm doing that right here. It's a single VI call where I am sending a message to the actor. It's giving me some data back right away. My 4 or 5 AF guys are probably looking at that going, how did you pull that trick off? And I pulled that trick off with a reply message. Okay, my AF guys, have you heard me talk about AF before? In any context? No hands. Okay. If you've heard me talk about AF before, I'm the reason reply messages exist in Actor Framework, and I tell you not to use them. Because you can get yourself in a world of trouble in a bunch of concurrent processes talking in parallel to each other if you've got reply messages. A reply message is like, please give me the last 10 data points as an average, and I'm going to stand here and wait until you get back to me. Thank you. Took you long enough. Meanwhile, I've backed up 47 processes, right? If you had a reply message and you sent it back to me at the same time, we'd be blocked and we'd be screwed, we'd be deadlocked, right? So we recommend against reply messages, except here. Except this is one of the very few cases where I'm going to say, yes, a reply message may be appropriate. That is where I am in a synchronous process like TestStand, like the web service, right? Web services is I'm going to post a query and you're going to do a calculation to give me the answer back, right? That's where a reply message might be appropriate. If you're not my non-AF guys, you're like, what are you talking about? And that's okay, because this is something that I expect the AF developer to handle for you, right? So again, the 4 or 5 AF developers I have in the room, I just gave you permission to use a reply message in this instance. You can say that Alan said so. Guess what? I can script the synchronous system too. And I'm not kidding about that. If one of you guys has a need for this scripting and a budget, we can talk. Because I think this is pretty scriptable. When I was writing this up, the templates were really obvious. And it's like, I take the template and I can write some scripting code to make a VI and fill in a VI. And I know how to do all this stuff. It's just a matter of having the time to write it from all the other projects I have. All right. Ooh, getting close on time. So I want to kind of speed through this. We're going to do something completely different. We are going to talk about, and I don't have a demo for this, so that'll speed things up a tad. We're going to talk about a distributed environment. A distributed environment is anywhere where I have multiple applications and a memory barrier. You know, they're different memory spaces, usually different computers, right? I'm talking across a network in this case, right? We know how to do this, right? We know how to do this. We use TCP/IP as our universal translator to talk between distributed computing elements. And they could be distributed on the same computer or different computer or, you know, same lab across the world, whatever. We use TCP. Why? Cross-platform, everybody supports it, right? So it is truly universal. My non-AF guys, you know how to do this, I hope. You open a connection, listener or receiver, or listener or initiator, whichever. You receive the message packet by some formula. You decode that message packet into something you know how to work with, excuse me, and then you act on it. This is supported in Actor Framework using something called network endpoints. They are another actor. So I have an actor, my QMH, right? And I need to broadcast, I need to send a message to a QMH on another system. I have this network endpoint. I send the message to it. It connects to a remote. Exact same thing on the other system. It flattens to string, sends the message, and then unflattens it and sends it out to the system. Supports TCP, free add-on to Actor Framework, right? And your AF developer likely knows how to do this. They know about network endpoints. They know to set up their 2 applications, my target, my host. They know to have the 2 endpoints and have them talking to each other. And then there are a few other things that they usually know to do to make the code elegant, right? That we don't need to cover here. Great. So if it's AF to AF, I know what I'm doing. I know how to do that. Solved problem, lots of documentation about how to do it. What about if there we go. What if I'm in this environment? AF to non-AF, or AF to something not AF, not LabVIEW even, right? I had to do this on a project. That's where this came from. We really only have to change one thing. We have to change how we serialize the message. Default network endpoints. Ever flatten a class to string? Anybody flatten a class to string? Would you give that data to anybody else to try to work with? That would be a horribly cruel thing. If they didn't know about your class structure or anything and you gave them a flattened class, what am I looking at here? Cruel thing to do. The good news is we don't have to do that. It's the default because it's easy, but we don't have to do that. This is the UML for network endpoints. If you're not a class-based person, don't worry about it. The thing that you need to know is that the TCP stream, when network endpoints are using TCP, there's a thing called a message flattener. My AF developer, when you're setting up the network endpoint and you say, I'm using TCP/IP, you get to specify the flattener you're using. You have to change how the messages get flattened. How? How do we serialize a message for transmission? I like me some JSON. Compact, human readable, cross-platform, hell, searchable in a SQL query if that's your thing. I like doing that. That's fun. That's good stuff. And I like using the JSON text toolkit from JDP Sciences because it's fast, easy, flexible, free. And I know Dr. Powell personally, he's a stellar human being. And I've had conversations with him about his stuff works when I need to figure it out, right? And I did this, exactly what I just showed you for a client about 6 years ago. And I did this whole, had to serialize every message by hand. I had to do that code for each of my messages, and it was kind of a drag. And then 2 years ago at GDevCon North America, Stefan Lemons turned me on to this, JSON Text Object Serialization by PNR. It is an add-on to JSON Text that literally that is generic serialization for a class. It will serialize all the data of the class, which likely includes some stuff you don't want, except their messages. And the only data in a message is the data we are intentionally transmitting. So we can break encapsulation, flatten to string. We don't care because we want them to have all of that information. And it's great because it nests. If my class data, if my message data includes a class, that'll all get serialized out as well. So I can write a JSON flattener. Again, it's a plugin to network endpoints. The JSON flattener will do exactly that, turn my message into a string. Actor Framework messages have priority. You just learned a new thing about Actor Framework. I have to attach that in order to be consistent, but that's easy because it's JSON. If I need to add some information in my serializer, done. Okay, it is a kindness, my AF developers, to give the non-AF person a VI that will take that big JSON string and turn it into the name of the message and the data elements. Right? That's a kind thing to do because then my non-AF person can do this and it's easy. Get the data packet, decode it, act on it. My non-AF person can go the other way, right? Take whatever my data is and the name of the message, put it into a VI that goes the other way, broadcast it back to me, transmit it back to me. I've given you the tool to build that message back up. And then in the unflattener, I just unwind the process. It is simple JSON manipulation, easy, straightforward. AF developers, remember, when you're getting messages from a remote, you have to guarantee the message is loaded into memory, and the only way to do that is with a cube drop. Non-AF people, don't worry about it. Flatteners let you play with endianness. If you've ever sent TCP to non-LabVIEW stuff, your strings are all backwards. So you can flip endianness around. You're allowed to do that. Okay, quick demo, just to prove that I am not lying to you. And that's in a different project because it's a different thing. I've got two VIs here. So I have an error reporter and I have my message receiver. It's an error receiver and it goes right there. Okay, cool. This is my listener, so I'll start him first. I'm gonna fire this up and now I have an actor. This is an actor. This is regular. I'll show you this text in a second, right? But I can send, I didn't send anything, did I? Ha. Error 43. Right? And you notice that it got echoed back to me because my message receiver round trips it. It receives it, deserializes it, acts on it. Acting on it is to post it, but then it serializes and sends it back. This is a toy problem that is all about, and everything crashes out because I did not do a good cleanup on that. But yeah, this is all about just demoing that the technique works. Okay. Okay, I think I've probably bent your brains enough. Okay. I taught you everything you need to know about Actor Framework in 5 minutes. By the way, I'm actually really interested in knowing how that part of this lesson worked for you guys. So anybody wants to give me a comment, come see me. I'd really like to know if that worked for you. I'm playing around with how I introduce Actor Framework to people. We talked about calling actors from non-actor code, actors in distributed system. Who here wants more Actor Framework? Cool, some more people want more Actor Framework. Excellent, because that's what we're going to talk about next. Very, very, very briefly in the scant seconds I have remaining to me. Have you seen the GDevCon 2026 events slide? Some of this content was from, actually some of it was from a GLA summit. We have 5 this year. I sponsor, personally, myself, the Chicago and European events. At the Europe event, or the Chicago event, I am doing an intro hands-on workshop, 3 to 4 hours. Come hang out with me the Friday morning after the event, real close by to where GDevCon is. Anybody going to GDevCon? Is anybody thinking about going to GDevCon now? Come sign up for my workshop. You do get to play with hardware in this. You can look at some of the CTI hardware in the hall. You get to use some of that. I will provide you with a kit, but you got to buy your ticket by May 31st if you want a kit from me. And that workshop is targeted at my non-AF people, right? 3 hours, get your hands dirty with some AF, figure out how it goes. Tickets on sale, go to GDevCon's website. If you want something more formal, I am slated to be the instructor for these next 2 classes from NI, instructor-led in Austin. If you want to come down to Austin, June is not terrible in Austin, Texas. And then the end of July, virtual instructor-led, which you can take from anywhere in the world. That's my GitLab. I will make, it's not yet public available. I will make the repo for my examples publicly available. That's how to reach me. Cards up here if you want one. If you decide to follow me on LinkedIn, you're invited to do so. Let me know you saw my presentation because I get people asking all the time. I just want to know where they came from. We are done. That was an hour. It only took 42 minutes at home, but that's okay. I will hang around. I will take additional questions until they drag me off the stage. I got to meet somebody in 15 minutes, but otherwise I can hang out and answer questions. Did I hurt anybody's skull with this? I hope not. One guy in the back. Right, okay. Give y'all something to think about?
So, what is the real benefit? I mean, if you're great at using handlers, and what's...
You're great at using DQMH. I'm great at using Actor Framework. We have to work together. That's what this is about. Was it you who used TestStand? You used TestStand? One of you guys back in that row there uses TestStand. You've played with TestStand. You are using TestStand. You want to use my actor. That's what this is about. The purpose for this is getting these different, but actually reasonably compatible with a little bit of work, environments to play well together. Actor Framework everywhere.
When do you decide to go from QMH to actor? Do you always just start out being an actor person?
Okay, so I woke up and chose, if I had woken up and chosen violence this morning, I would say you go right to Actor Framework. Right. But I did not choose violence this morning. You wind up going through QMH. I think it's important to learn QMH because really all of our architectures use it at the core. I would want to get you onto one of the frameworks. I am the Actor Framework evangelist, so I have a preference. It does not cause me, I don't lay awake at night thinking all the people who go off and do DQMH, because a lot of people are very successful with that as well. Getting onto one of the regular frameworks is good because it does give you access to code developed in those frameworks. For example, DQMH does not have a drop-in solution for network endpoints. They can do it, they just have some extra work to do. It's a drop-in solution. If you want to use that network endpoint, you download the package from vipm.io, you install it, and you call an actor from inside of your actor, and you are now talking across a network, right? The whole idea of being on somebody's platform is you can use the full tool set. And there is a lot of cool stuff. There's a sequencer. Somebody's got a whole test sequencer for DQMH. So if you're on DQMH, you can gain access to that. I have an Actor Framework sequencer, which I haven't published, but which I share. I haven't published it yet. I don't know if I want to. I keep telling people to use TestStand. They never listen. So yeah, I would look at like the common frameworks when you can, just so that you're on a consistent page with other people.
There was a nice presentation earlier on Actor Framework.
Yeah.
It kind of showed the evolution of going from a QMH to Actor. Kind of baby stepped us through it.
Yeah, I talked to Daniel. I talked to him. I'm going to grab his slides because I wrote the Actor Framework course from NI, and I'm rethinking how we introduce. That's a design class, and that does expect a deeper level of knowledge. But I think it's been kind of a disservice to the community that we don't have how can I ease you into this set of of materials. And the workshop I'm doing will eventually be in the community training initiative available for other people to look at. So yeah, I had to go to something else. I wanted to see, just to see what he was doing. But I am going to look at his slides and see what, because he's an FAE. He's talking to people who are new to this stuff. So I think his perspective will be really interesting.
Yeah, the parallels you drew with QMH at the beginning really was very helpful.
That worked for you?
Yeah.
Good. Nancy Henson had been begging me to do that for a couple of years, but I had to you got to get far enough in to be able to come back out. And I'm like, no, we don't need that. No, I'll just tell them about that. Like, no, actually.
Yeah, just showing it how the case structure is just a message.
And I have thoughts on that whole set of stuff I want to develop to actually do exactly that. And if you can, then you can take and apply all that knowledge to DQMH because you've got that QMH sitting on the block diagram right there. So thank you for that. I'm glad to know that worked for you. Yeah.
So other than community and toolkits, what about performance or creating logics? Does it get better when I go from DQMH to Actor?
Well, your logic and your work is going to be done inside queued message handling, and or a helper loop next to. Remember what I showed you? I had the short process actor, and I had the stuff that I was doing down here. That can actually be a processing loop. If I need to do something very performant inside of Actor Framework, I'm going to have a helper loop sitting aside message handling that does that high performance stuff. And then
like DQMH, right?
Yeah, kind of like DQMH does, yeah. Or a long process, right? I've got something that's going to take forever. And I need to
like acquiring data continuously.
Yeah, running a test sequence.
As I understand, there is no any difference in process.
I don't believe there's any difference in performance between if you do it wrong in one or the other, right, you can make your own performance problems. But I think just I don't believe there is, DQMH is the extra step of receive, and I have done a little DQMH. I need to put that out there, right? So anything I say, you should check against somebody who does it a lot. They have the event structure that they catch messages with, and they pass it to their message handler. And their whole reason for doing that is for long process, so they remain responsive. You can do that in Actor Framework. We just don't insist that you do it every time. So they're by default set up for long process. You can have an Actor template that's set up for long process, or a high performance process. AF runs on compact RIOs, for example. And if I'm doing something that needs rigid timing, I'm putting a timed loop as a helper loop in an actor. And I might have 3 or 4 loops to do all that stepping between message handling and that. So, yeah. But innately, they're all parallel processes that talk to each other. They're all non-deterministic. They're all perfectly capable of getting bottlenecked, right? You got to do your job, but the framework itself doesn't impose any unusual restrictions.
I'm just curious, will I ever need to move to Actor Framework from DQMH? Need is another thing, but I'm curious. I'll look at it.
Okay, I say this from somebody who does not have deep knowledge of DQMH. I have done a little bit of it. One of the reasons I haven't pursued it is I do think that you'll reach a point where it's easier, since size and complexity of your system. I believe that there is a point where it would be easier. 2 systems of comparable complexity, DQMH, Actor Framework. I think you'll reach a point where it will get too hard to proceed in growing the DQMH system. I don't know where that limit is, and it's probably farther out than I intuitively think it is, in all fairness, because I know there's some pretty big systems out there. But I think for most LabVIEW developers, most of the time in most scenarios, you probably don't have to go. You don't have to give up your DQMH. But I would like to make it so that if I have a cool tank monitor, that you can use it. That's a gift to you. So that we don't have to, the 2 frameworks don't have to be natural. And really are the same thing. It's like getting the Spanish and the French to work together. It's just got to get the language.
You're that guy as well.
Right.
Anyway, my colleague, and he's an AI creator, and I'm using DQMH, so this is fun.
So now you guys can talk to each other. Now you have a translator. You can go hang out in the Basque country up in the mountains and in the Pyrenees, and you can sit back and have some wine together.
That was helpful, by the way. I agree with you.
Okay, good.
The comparisons and with parallel. Sure.
Awesome. Yes, sir.
I have a spicy question.
Sure.
Have you ever considered?
No. Have I ever considered?
Have you ever considered shipping something like monitored actor with actor framework?
I hate monitored actor with a purple passion.
Really?
Yes, not because of what it does. Derek Depane used the tools that he had to solve a very real problem, and I do not fault the man for that. Monitored actor inserts something into your inheritance structure, into your inheritance tree. It forces everything. Everything inherits from monitored actor, which sucks, but my network endpoints don't inherit from monitored actor. Okay? If you pull in a network endpoint, you cannot monitor it.
Which is kind of why I was asking if you guys consider
I don't like the overhead of those things that are in there.
something into actor framework.
Go look up the actor hierarchy inspector. It does most of what monitored actor has, and we're talking about ways of filling in the gaps. But it will show you the full running actor tree, and it will let you manipulate individual actors. And the whole point of that is to take away the need for monitored actor.
Do you know what version that was added?
Actor Hierarchy Inspector, it is online, available from vipm.io, and my daughter and I were talking to people about it in 23. So,
I'm probably just a little bit too bad.
yeah, 2020, it's LabVIEW 2020 or later, so whatever version you're in, it'll run fine. But yeah, I would go look at that. If there's something missing from monitored actor that you want, from Hierarchy Inspector that was in monitored actor, let me know, because we'll look at improving that. I have a version of panel actor, which does not inherit from monitored actor, which I have MGI's permission to publish, and I just haven't gotten around to doing it yet because I'm not quite sure it's ready. All right, they're probably gonna kick me out, but I'll take a last question.
Well, last one for me.
Yeah.
So DQMH, they have a really good shipping example, like a thermal chamber, and it shows you how everything works. That shows you how everything is, connected. Is there a good example on the example finder that can get you with the AF?
It needs an update, but you can go look at it ships with LabVIEW, and it is the coffee shop example, and it actually comes with a PDF of like. There's a PDF that describes it. It was an IEEE magazine article on concurrent processes.
So if you're in the example finder and you search actor framework, there will be
I believe so, yeah. I can't remember quite what it's called. It's a little dated. It doesn't have interfaces. And so you might see some stuff that's like, what am I looking at? My workshop stuff will actually be made public after my workshop this summer. It'll be part of the CTI. So you'll be able to pull that down and look at it as well. All right. I think I gotta be done. I think they're gonna throw me out. Thank you all for your time. I have a little bit of time to answer questions off the stage. If you have any more, grab a card if you want, find me on LinkedIn. Thank you all.